Hello everyone, we are going to talk about word embeddings. I am Aishwarya Kulkarni
And I am
and
Aditya Singh Verma.
the paper we have referenced is Efficient Estimation of Word Representations in Vector Space.
By Milkov, Chen, Corrado, and D. So for computers to interpret numerical data like audio and video, it is not such a difficult job. Frequencies and amplitude can be encoded in vectors and they are easily interpretable by a computer. But what about words? For So it is very difficult for computers to interpret words from human natural languages like car and vehicle, even though they might have some a relationship in a human context. It is very difficult for a computer to find out the relationship, and it's for this reason we use word embeddings. So before we get into word embeddings, we'd like to talk about vector space models. So VSMs or vector space models represent a continuous vector space. So it relies heavily on the distribution hypothesis, which states that two words which occur frequently together in the same context might have similar semantic meaning. There are different techniques to leverage vector space models, and how they work is they take an n-dimensional space and they place similar words close to each other.
So coming to count-based methods compute the statistics of how often a word co-occurs with its neighbor word in a large text. For example, how often does Manipal occur with university together in a large text? It then maps these count statistics down to small, dense vectors for each word.
The next methods are predictive methods.
Predictive models directly try to predict a word from its neighbor in terms of small, dense embedding vectors. Word2Vec is an efficient predictive model for learning word embedding from a corpus of data. We can use two different types of algorithms: continuous bag of words model and the skip-gram model. We are going to focus on skip-gram model in this video. And next,
I'll talk about word to vectors. It has two different varieties. One is the continuous bag of word model, which takes a context and tries to predict the word which is about to occur in the future. Like this is often used in softwares like SwiftKey or Google Keyboard, which predicts what you're going to type next. The other model, on the other hand, the skipgram model, takes a target word and tries to predict what context it occurred in. So we're going to focus on this. So we will use a softmax function to maximize the probability of the next word, that is the target, given the previous history. So it works. It works on the principle of Bayes' theorem. Like it tries to predict what is the probability of the occurrence of the next word. It takes the probabilities of each and every word which is in the bag of words, and the word with the maximum probability is selected.
okay, so the score seen in the previous formula for softmax function computes the compatibility of the word w omega t with the context h using dot product usually, and we train this model by maximizing its log likelihood function on the training set, and this is the formula we use, but this is computationally expensive. So since the softmax function is computationally expensive, we use a word2vec because it does not need a full probabilistic model, and the skipgram model is instead trained using logistic regression to discriminate the real target words from the noise in the.
So this model represents the classifier. It takes each and every word in the corpus and tries to predict the probability of that word occurring next. So it is a computationally intensive approach. So we have our objective is to maximize
Mathematically
this function. It's a logistic regression probability that that word is going to occur next, so that we can learn our parameters for theta.
So the skipgram model, where we aim to predict the context from a given word. Example,
So if you have a corpus of data like the quick brown fox jumped over the lazy dog,
And
so
the data set is
it will take words, it will take each word and then take the word to the left and to the right of it and try to predict the central word. So the brown is the target, is the label, and quick is the target. But skipgram, this was for the previous approach. Skipgram inverts this. Skipgram, you have you reverse the labels and the target words. So quick is your feature, and the and brown are your target variables. So how it works is you have you use the gradient descent algorithm. You write a cost function for this to predict the occurrences of words, and our goal is to find the parameters theta, and as we go on and improving this function. So that's done by using gradient descent, which we also studied in class. A random theta is taken, random values of theta is taken, and alpha, that is a learning parameter, is initialized, and we keep iterating over and over again until we find the values of theta. So by the end of it, we are left with an n-dimensional graph in which words are represented in space. So words have been learned, and words that are similar in meaning to each other are placed together. Words with different meaning are kept at a distance from each other. So thank you.
Thank you for watching. Bye.